Hey pre-calc, we are there. We're in our last video for chapter 2. This is graphing with an oblique asymptote. So what is an oblique asymptote other than a fun word to say? So oblique asymptote so an oblique asymptote is a linear asymptote that is neither horizontal or vertical. Right, so we've learned about horizontal asymptotes. There are 3 different cases. We learned about vertical asymptotes. It occurs when the denominator is undefined. So, when does this happen? A graph has an oblique asymptote if the degree of the numerator is 1 more than the denominator. Which we've actually mentioned before, if you remember. So it's only 1 more. So the degree of the denominator is 5, the degree of the numerator is 6, then there's an oblique asymptote. So if the polynomial in the numerator is a of x and it's to the nth power, and the degree of the denominator is b of x to the m power, we have an oblique asymptote if n is m plus 1. And I mentioned this actually, well, not with oblique asymptotes, but we talked about this. This is the case for horizontal asymptotes when there isn't one. So if there's no horizontal asymptote, then there's going to be an oblique asymptote if it's specifically 1 higher in the numerator. So then that's it. And we'll talk about how to find the asymptote now. So to find the asymptote, you need to do long division. Find the equation of the oblique asymptote. So here's our function f of x. The numerator is 2x cubed plus 3x squared minus 5x plus 1. And my denominator is x squared minus 4x plus 1. So the degree of the denominator is 1 less than the numerator, so there is an oblique asymptote. So to find the oblique asymptote, all we do is some long division. So we take what we're dividing by, right? We just divide this really and see what we're left with. So x squared minus 4x plus 1. How many times does that go into? 3, 2, 1. Okay, there's no placeholder, so 2x cubed plus 3x squared minus 5x plus 1. Alright, so what times x squared will give me 2x cubed? It's 2x. Two x times negative 4x is negative 8x squared. 2x times 1 is 2x. Make sure you put this in parentheses and subtract. A lot of you did not do that on your quiz and lost points. So 3 minus negative 8 will be 11x squared. Negative 5 minus 2, negative 7x. We can bring down our 1. So what times x squared will give us 11x squared, positive 11. And then, I mean, really we're done, but we should probably work on our long division after creating the quizzes. So 11 times x squared, 11x squared, 11 times negative 4, negative 44x. 11 times 1 is 11. Put it in parentheses, subtract, don't forget your bar. These cancel. Negative 7 minus negative 44x is positive 37x. And 1 minus 11 is negative 10. Now we actually don't care about this at all. Don't care. We care about this. So the equation of our oblique asymptote is y equals 2x plus 11. And that's that. So technically speaking, you can stop like right when you get this and write your equation. You don't have to finish because we don't actually care about the remainder. All right, so let's try to do an example. Where we graph. Okay, so graph f of x equals x cubed plus 2x squared minus 9x minus 18 by x squared plus x minus 12. So we learned the other day we want to check to see if we want to try to factor this as much as we can to see if there's any holes and if it simplifies. So the numerator factors to be, and you're just going to trust me because there's not that much time in my recording left, x minus 3 times x plus 3 times x plus 2. The denominator, this one is easy to figure out, x minus 3 times x plus 4. So then my x minus 3's cancel, and I'm left with x plus 3 times x plus 2 over x plus 4. Okay, so remember that for the domain, we want to set the original denominator, which I already factored, equal to 0, or not equal to 0. So that means x cannot equal positive 3 and x can't equal negative 4. Some of you forget to do this in your classwork, but you need to write the domain now. So negative infinity to negative 4. I don't know why I put a comma there. Union negative 4 to 3, union 3 to infinity. Okay, vertical asymptotes. We'll be setting the denominator equal to 0, but this is where we want to set, excuse me, the simplified denominator equal to 0. So that means our vertical asymptote will be at x equals -4. Horizontal asymptote. So because the degree in the numerator is 3, and 3 is 1 more than 2, there is going to be none, which means that there is an oblique asymptote. So for this, we do long division, and again, we need to use the original. So x squared plus x minus 12, how many times does that go into x cubed plus 2x squared minus 9x minus 18. So to get x cubed, we multiply by x. Subtract. And we get x squared plus 3x minus 18. And that's just going to be plus 1. So my oblique asymptote will be at y equals x plus 1. Alright, so now I need my x and y intercepts and then the whole. So for x-intercepts, remember that's when our function equals 0, so I'll have 0 equals, and this is again going to be the simplified version, so x plus 3 times x plus 2 over x plus 4, multiplied by the denominator. Zero product property. So our x-intercepts are going to be at -3 and -2. Don't forget to write them as coordinate points. Alright, y-intercept. So this is when x is 0, and again, don't forget to show your work. So what do we get? 3 times 2, so that'll be 6/4, which is 3/2. So our y-intercept will be 0, 3/2. Alright, and then the whole is going to be at x equals 3, because on the other page, right, that's what canceled. So I now need to figure out what is the y value. And we want to substitute this into the simplified version as well. So this is 37ths. So our whole is going to be at 3, 37ths. Alright. So I'm going to set up my graph and pause the video because I only have like a minute left. And then I'll go over it. Okay, so here's my graph. I graphed everything I knew. I graphed my asymptote at x equals -4, my asymptote at x equals x plus 1, make sure they're both dashed and labeled. I plotted all the points I knew, my x-intercepts, my y-intercept, my hole. Make sure it's clearly an open hole. If it doesn't look open, you will not get credit. And then I plotted a couple extra points to make my graph accurate. Because of the oblique asymptote, I know there's going to be something on one of these. This was pretty easy, but I wanted to make it a little bit more accurate, so I graphed a point -2.5, and then for here I did -6 and -5, but I wanted to know where the curve was specifically, so I did -5.5 as well. So that is a graph with an oblique asymptote and a hole. And that's it for this chapter.